Yep. Great.
It is
Thanks.
fine? Okay.
Yep.
Thank you very much for giving me a chance to introduce our research on heat stroke among students. Today, I'd like to discuss with you psychology, culture, and group dynamics as risk factors for heat stroke among students during heat wave. So we are more focusing on downstream of the value chain, like health impact of communication science or behavioral psychology. So regional heat wave characteristics such as intensity, frequency, and durations are projected to change due to climate change, which can enhance heat stroke risks in some regions. Current research on heat stroke has predominantly examined hazard and exposure factor as a cause of health impacts. They assume that heat strokes are mainly caused by prolonged exposure to extreme heat environment, limited water intake, and failure of temperature regulation of one's body. For example, in 2005, the Japanese government uh, introduced the early warning of heat wave using WBGT and started taking action to reduce heat stroke. Also, for prevention, the government has emphasized three main factors: environmental, habitual, and behavioral factors that would cause heat stroke, as shown in this figure. Okay. However, the number of deaths due to heat stroke in Japan is not declining as shown in this figure. The question is, how can we reduce risk factors of heat stroke? So we have focused on behavioral and psychological biases to reduce heat stroke risks. So disaster science has studied biases related to disaster evacuation and risk mitigation behavior, such as from tsunami and flooding and earthquake. We hypothesize that the study of disaster evacuation and risk mitigation behavior might be worth of referring to for action to reduce heat stroke risks. Disaster risk has identified the following biases related to evacuation and risk mitigation behavior from natural hazards. First, normalcy biases, which result in underestimating the probability or extent of expected disasters. So for example, people tend to think like this is normal, even if the disaster is not normal situation. The second one is comparative optimism biases. So people tend to think that I am fine even though they are not fine. So it's relative. People tend to think only ourselves are fine. The third bias is availability heuristic bias. This bias will occur when people only rely on their past safe experiences. For example, in the past, tsunami didn't come to this area. That's why this time is okay. And the last one is majority thinking biases. This will follow other people's behavior. Even if uh, a situation looks dangerous, but if other people around you don't evacuate, they follow their surrounding people. In addition to these conventional biases related to disaster evacuation and risk mitigation behavior, we will look at other group dynamics and cultural factors such as competition and gammon, which is a unique culture in Japan, which indicate where patience and endurance are respected value. So even if they don't feel, for example, the example of this culture gammon, even if they don't feel well under extreme hot weather, people will not give up, running, for example, in a field. So the research question we are asking in these studies are the following. First, do psychological and cultural factors increase heat stroke risks among junior high school students in Japan? The second research question is, if so, what kind of models are suitable to analyze these risk factors? The methodology is the following. We conducted questionnaire survey with junior high school students in one city, Amagasaki City, which is a city close to Kobe and Osaka, Japan. We conducted two surveys with an interval of 2 weeks in July and August. And between these two surveys, we conducted a workshop to randomize students between two surveys, so-called randomized control trial. One is the one workshop is about heat stroke. However, the other workshop is about non-heat. So we are trying to measure the effectiveness of knowledge about heat stroke among students. The number of surveyed students are 160, with response rate about 90% for the first survey and 86% for the second survey. There are three main categories of questions in the survey. The first questions are related to everyday habit of students, such as eating breakfast or having sufficient sleep. These factors are important factors to prevent heat stroke. We also asked heat stroke related questions such as the past experiences of heat stroke of students and their family, friends, and acquaintances. The third type of question is we asked questions related to evacuation or risk mitigation behavior following the previous disaster science literature, Autumn and Hirose in 2007, which examines disaster evacuation and risk mitigation behaviors. So let's look at the result of this survey. So first, the basic result. For example, the past experiences of heat stroke among students are shown here. Interestingly, the ratio of expressing that they have experienced heat stroke has increased from 33% at the bottom one to the 39% after the workshop. The first bar is the first survey, and the second bar indicates the second survey. Also, the left figure shows most students recovered from heat stroke when they took a rest or water. In contrast, 25 students answered their family, friends, and acquaintances are brought by ambulance. The right figure shows that more students in second survey than in first survey answered every choice of how their family, friends, and acquaintances recovered from heat stroke. We also asked if they feel it is difficult to say that they feel sick during class, or to say if they are thirsty or need to drink water, or if they are sick or unwell during a club activity. 39% or 21% of responded students answered it is difficult to do so during class or club activity, respectively. These might be due to cultural factors of Japan. We would like to compare these results with other countries in the future. The next is about analytical framework to examine these psychological barriers to taking action to reduce risks. So for the analytical framework, we rely on disaster evacuation and risk mitigation model proposed by the previous research, Otomo and Hirose in 2007. So they built a model of analytical model using structural equation modeling with these 7 psychological factors. Like each factor are connected to each other, and for example, they include risk perception or other people's image, so that how they are having typical image to risk can be measured by prototype image, for example. So their model is built connected each other like this. The first group, the upper group, is about how situation affect their decision making, and the below group, like with 4 variables, it's more related to goal-oriented decision-making processes. So these two groups affected how they mitigate risk behavior, and they constructed this model with structural equation modeling. So these previous study was designed for earthquake and tsunami evacuation and risk mitigation behavior, but we try to use this for risk for heat stroke behaviors. So firstly we revise the original model to see how these model will get better. For example, we change the arrow direction between different model or different variables, for example. And we tried several different models, like how they are affecting each other among different variables. And for the originality of our research, we also included the student past experiences of heat stroke and cultural factors, including the measurement of valuing conformity, harmony, and independence. So these are like cultural and psychological factors. We are using existing measurement from psychological literature. So we compared these our model that include culture and group dynamics variable with original model which are developed for earthquake and tsunami. So we compared. So the model 1, 2, 3, 4 are more based on conventional disaster model, and the model 5 and 6 we are adding other variables such as group dynamics and cultural factors. So for example, so these are the model measurements. So for example, CFI is better if the value is higher, and the TLI is a better model if it's closer to 1. So if you compare with a different model, if we include group dynamics and cultural factors, model performance gets better. So as a conclusion, our results show that risk mitigation behavior for the heat stroke is a little bit different from risk mitigation behavior for conventional disasters such as earthquake and tsunami. And if we include student past experiences of heat stroke and cultural factors, the model performance becomes better. However, the previous model, like a goodness of fit indicators, actually these are not so good so far, and the model fit good even if we include group dynamics and cultural factors. So therefore, we have to still need to improve the structure of model, and we might have to include other like hidden variable to improve the understanding of risk mitigation behavior and risk perceptions. So for future study, we are going to try to other method to analyze collected variables. Also, we will collect more data from other cities in Japan. And also, we will compare with these results with the Kuala Lumpur in Malaysia to see how how cultural factors differ from country to country. And we are always looking for partners, so please let me know if you are interested in this research. And thank you so much for your attention.
Okay, thanks, Masahiko. also very interesting study. Any questions, Brian? I've seen at least one question in the chat.
I think you offered one. I certainly have a question as well. So go ahead with yours if you want, and then I'll follow or see if anyone else pipes in.
Sure. So, I mean, you kind of answered it in your very last bullet point, but what I find really interesting is the role or the importance of cultural factors. And so I was wondering what other countries or regions you're considering for your research. You mentioned Malaysia, but have you considered Western countries, perhaps in North America or Europe, for example?
Yeah, I think if I can find that, because we are working with schools and asking questionnaires to school students. So if we find good partners in different countries, like teachers are more supportive for this research, we are happy to conduct research. But so far we have identified collaborators in Malaysia, so we are planning to do so in Malaysia. Thank you so much.
Okay, thanks.
I just, if I could